There we go.
Live. All right.
Okay. So we have two files we need to download right off the bat.
Yep.
And T-distribution applet.
All right. So, let's see. Question 3 says, what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply. A simple random sample is drawn from a population. That's yes.
Yes.
The mean is normally distributed from each group. That's yes.
U is greater than 0. I don't think that's a requirement, is it?
That's not a requirement. Yeah. And then the sample size must be the same. I didn't read about that. I mean, I'm assuming they would, but
I don't think that's true because the dev and gen group were not the same size.
Okay. Yeah, in the reading it only talks about 2, and it says a simple random sample is drawn, and the mean is normally distributed. So yeah. So the first two, A and B.
Okay. The test statistics for a hypothesis test comparing two means with independent samples is a t-score, right?
Yeah.
Not a t-score, right? That's what
yeah, t-score, yeah.
Okay.
Yeah, because we still use that t-applet.
Oh, that's right. That should have been a dead giver. Yeah. There's no such thing as statistic.
Yeah, not yet, at least.
Yeah, fair enough.
Yeah. Two samples are independent if knowing which subjects will be in group 1 determined. Nope, that's wrong. Knowing which subjects in group 1 will tell you nothing about. Yeah, so group question or answer B. Group 1 tells you nothing about group 2 because they're independent.
We need the dentist office bills app. Or not app, file, whatever. Throw that there. Okay.
Did you get it all pulled up? Let me know when you're ready.
Yeah, I'm just adding it to that app.
The thing. Question 6 says, what is the degrees of freedom? Actually, speaking of that real quick, that was something I found interesting in the reading, that the degrees of freedom does not have to be an even number. Because like previously, did we read that the degrees of freedom was equal to n-1, but all of a sudden this thing is saying, well, if you get a degrees of freedom that's point something, 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 just put that in your answer instead of an even number. I was like, well, that's interesting.
Yeah, I don't know when we would get that, though. How are you going to only have like half of a sample?
Yeah, I don't know. I just found that. I was like, well, that's contrary to what we learned last lesson, but I guess maybe that'll have some place eventually.
So degrees of freedom, I'm getting 19?
Yep, that's what I got.
Okay. And then what is the sample standard deviation for Rexburg? I'm assuming that's just this.
I'm assuming it's at 206.637, right? Because it's a standard deviation for variable 2.
Is that what the...
That's what Rexburg is, yeah.
Oh, Rexburg, yep. I wasn't paying attention to which was which. Yeah, so 206.637. Oh.
Test statistic, which is what? T, right? So negative 0.426.
Yeah. Negative.
P value is 0.337.
Wait, 0.337? Am I getting something wrong here?
Did you put your alternative hypothesis as less than?
Oh, no, I didn't. That's gone.
Actually, hey, just a question. Do we need to change our confidence level to 0.90 because the level of significance is 0.10?
Ooh, I don't know.
Because I know for the most part, that's why we use a 95% confidence margin when our level of significance is 0.5. They were saying together they have to equal 1. So it doesn't change any of our answers so far.
Yeah, I was going to say it didn't change anything. So 0.337 is what you're getting?
Yeah.
Value?
Because under that summary statistics where it says confidence level, null hypothesis, and type of test, if you change that, it changes the stuff under the paired sample t-test differences box.
Yeah. I just changed the point, and yeah, I didn't see any different. Well, let's leave it at that, and we'll see what happens.
Okay.
What is the correct decision based on this? What?
I was just going to say, if I start talking over you, you're kind of breaking in and out. I don't mean to, just because I don't know that you're talking, because you're a couple seconds delayed.
Okay. It's okay. I'm all right with that.
Okay. I just don't want you to be like, well, this guy's rude.
No, don't worry about it. Technology sucks sometimes. All right.
So we're on 10.
10.
Right?
What is the correct decision? Yeah. So where it's 10, we're over it. So we failed to reject the null hypothesis, right?
What was that? You cut out.
B. Question 10. I'm saying B.
Yeah, that's what I put.
Is greater than. Let me try refreshing this and see if that fixes it.
Okay.
I'll be right back. Any better?
Yeah, for now.
Okay. Go with that. Okay.
Question
suppose
11.
Instead you had. Go for it.
I was going to say question 11. Suppose that instead you had used the alternative hypothesis that does not equal. What is the correct decision? So we go to that thing, we change it to does not equal, and the p-value is still greater, so it would be that we could still fail to reject the null, which means what? We have significant evidence or sufficient evidence that they're the same.
Mean dentist bills between the two are. We're trying to determine that they're on. I'm trying. Hold on. Okay, yeah, that they're the same. Yeah, because
so C?
See if they're different. Yeah. See. Yeah. Insufficient or sufficient?
I'm not sure. Like, this is one of the questions that I always seem to struggle on.
I would say we have sufficient evidence if we're rejecting the null hypothesis. Oh, no, we failed to reject the null hypothesis.
Yeah, we failed to reject the null hypothesis, which means
right.
But
we have insufficient to show that.
Isn't there some? I don't know what I'm talking about. So I mean, it's either C or D, right?
Let me see something real quick. Hold on.
Okay.
Okay, so if p-value is greater than alpha, we fail to reject. We have insufficient evidence. So I think it would be B, because the null hypothesis was that they were different.
No, the null hypothesis is that they're the same.
That they're the same? Hold on.
Yeah, it's the alternative hypothesis that says that Idaho Falls is less than Rexburg.
Right. So you're right. It is D.
D?
C is in dog.
Yeah, okay.
Okay, now the next one, freshman dinner.
Yeah. So the next one says, basically, we suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is that they're the same. Use a significance level of 0.05. What is the appropriate alternative hypothesis? I'm going to say B, because it just says that it's different. It doesn't say greater than or less than. So I would say B does not equal.
agree with that.
Pull up the
So
data right now.
Let's say 92.9. Okay. So what is the test statistic? I'm getting 0.8 for you're getting?
You're getting what?
Oh wait. No, hold on. Let me try this.
I'm getting 1.45. I'm getting 1.225.
Okay, let's see. Hold on. I'm still getting that. Which app are you using? Are you using the 2-sample t-test?
Nope. That would explain it. All right, hold on.
Because we're not working with paired samples anymore, so that's where I just switched to that one. So I might have the last numbers.
Yeah, I'll have to go back and do those real quick. Dang it, my bad.
No, mine too. I mean,
I'm getting 0.845.
Yeah, that's what I'm getting.
And then I'm getting p-value of
P-value
0.40 or 0.411.
Yep.
Technically.
Yep, that's what I'm getting. We reject the null hypothesis because it's less than.
No, it's greater than. Isn't the
Wait, my p-value is right. Never mind. I was thinking 0.5. You're right. We failed to reject null hypothesis. Right.
Yep. So for this one, this is one that we missed the other day.
Yeah, margin error.
And I think what you do is you find the difference between the two.
So we subtract.
So you add up together and divide it by 2.
Oh, okay. Okay. Make that.
Because that's what I did for the homework assignment, and I got it right.
Okay.
So the margin of error, I believe would be 3.681. 3.681. Well, for the margin of error.
What are you adding together? Okay. Oh, okay. I'm doing the wrong.
Because remember, your confidence interval is going to tell you that you're confident 95% of the things are within these two numbers. So your margin of error off the mean is going to be plus or minus the margin of error, which is going to give you your confidence interval.
Gotcha.
So you're kind of going backwards to solve it.
So wait, where you get? What did you say you're getting?
I got 3.681.
And I am not getting that. Hold on.
So it's important to remember that you subtract the negative because you want the whole positive number, but you cannot add the 5 plus the negative 2. Otherwise, you only get like a 3.
Okay. Yeah, 3.68. 1. You get 3.681. Yep. Okay. Input the lower bound, negative 2.214.
Yep, same.
Upper bound is 5.147.
Yep. So I'm pulling up the other numbers real quick. We'll throw those into the correct.
Yeah, check those. I'll do the same.
Although I don't know that it would change too much because they had an even number. I mean, the degrees of freedom changed a little bit.
37.996. Is that what you're getting for the degrees of freedom on that one?
Yep, 37.996.
Yeah.
Standard deviation stayed the same for number 7. The test statistic changed a little bit. I'm getting negative 0.434.
Wait, which one is this? Sorry.
For the test statistic, I got negative 0.434.
Yeah. Yeah.
And then the p-value, I got 0.667.
Yeah, 0.667. Yeah.
Actually, hold on.
And then that changes everything because no, that doesn't. We're still we're under. We're over. We're still over. Never mind. That changes if we.
My p-value is actually 0.333 because I had to change the type of test to less than. So if you change it to less than, it's 0.333. And then in question 11, when you change it to does not equal to, is that 0.666. So the answer for number 9 is 0.333, but then in question 11 is the exact same because in both cases, we fail to reject the null as the p-value is greater than the level of significance.
Right. Okay, so that's all of it.
Yeah.
We submit?
Yep, we'll submit, see how we did. Hopefully we know what we're doing.
Yeah, I hope I got it all right.
16. No, we missed a couple. We got 16 out of 19. We missed 17 and 18. And then we missed 13 and 11. So for number 11, I'm thinking it's C.
You think it's D? Like D as in dog?
No, C.
Oh, C. Okay.
Because I'm thinking if we have enough to say like, hey, we're not gonna reject this, I think it's sufficient evidence to say that they're the same.
Gotcha. I'm curious how we got 13 wrong. Unless it was supposed to be equal to. Let me see something.
What was that?
Sorry, I was just trying to figure out why we got 13 wrong. Because I'm still getting the same answer.
Let me pull up that data real quick again. See.
So the null hypothesis is hold on. Freshman from Utah and Colorado cooked their dinner.
I don't see what is wrong because it's the same. I'm getting the same answer.
Yeah.
Hold on. Nope, that doesn't change it.
So
I don't know.
I'm meeting with a tutor online in about 45 minutes.
Okay.
I can ask them.
Yeah. If you want to ask and then just shoot me an email because I got to get ready to head to work right now. Sorry, in a couple of minutes. Yeah, I don't understand it because we did the exact same thing we did for question what is it? 8. And we got the exact same, and like we did it the exact same way and got that one right, but then all of a sudden we don't get this one right. Like, and I'm double checking all of our numbers. I changed my confidence interval, which didn't affect it. I changed the type of test, that doesn't affect it.
What does it mean? Assume equal variance?
I don't think we've learned that yet. So I
Okay.
think that's why it says no unless told otherwise.
Yeah.
But I don't remember reading about that. But even if you change that to yes, like that doesn't. I guess that does actually affect things.
0.867. Wait, hold on. Isn't that what we put down though?
No, we put 0.845.
Yeah.
Maybe that is what it is, because if you look in no, because that changes the p-value, but we got the p-value right using the same exact numbers. It's just weird that our test statistic is wrong, but our p-value is right, and our margin of error is right using the confidence interval, but those are wrong.
Yeah.
Like, that's what I don't understand. Like, if we got them all wrong, it'd be okay. Well, we used something, crazy somewhere, but
yeah, no, and
what we did.
That's frustrating.
Yeah, if you find out anything, just shoot me an email and let me know.
Yeah, I
I'll
can
try
do
to
that.
look into it more and see if I find anything that, oh, hey, here it is. Yeah, this is why we didn't do it. So,
Gotcha. Okay.
I'll shoot you the link for the meeting so you have it.
Awesome.
And then, yeah, just let me know if you find out anything.
Sounds great. All right, man. I'll see you Monday, right? Yeah, Monday.
Yeah, I believe it's Monday that we have that thing. So I'll see you later, Matt.
All right, man. See ya.